Ain't it fun?
What happened to like 2 plus 2 equals 3?
It's for amateurs. We're pros.
No, I definitely want to go back.
What time is it? Holy monkeys.
Game time.
Dinner time?
Lots of time or a little time?
We got lots of time.
No.
That's where we get into a little bit of gauss. That'll be fun.
No.
Can we just give like a little bit of hot gals?
Oh, okay. I got an ugly number.
Rather get into like regular bird watching.
Anyone get hay yet?
Huh?
Anyone get hay yet?
Alright. Whoopa.
Hold on. Like I just.
Focus ring.
Oh no, A isn't A 0.05.
Whoop.
It's
The argument, 5 centimeters, 0.05.
Oh yeah,
It matters.
it's like
angle.
922.
This is KQ over
9220734.
distance
We did
squared
something in the realm of
cosine theta.
10,000.
So
Like,
9 times 10 to the 9th times
you know that.
8 times 10 to the negative 6th all over the radius between the two, which is going to be the. We figured out that which form are you guys using? You use the cosine one or the other one? You use the other one, right?
I'm using the cosine one because it doesn't show you.
X is going to be, so x over the square root of, not the square root, 3/2 root. Well, I'll go ahead and do it the whole way. X squared, I said I was going to do it the other way, so I just do it that way. And then the distance between the two is going to be this, which is the square root of x squared plus a squared. I'm going to plug down here, which squares that, which is x squared plus a squared, right? Rewritten, I get 9 times 10 to the 9th times 8 times 10 to the negative 6 times the distance between the distance the x direction divided by, in this case, x squared plus a squared. A is the ring, right? Width of the ring. So that's just going to be 0.05 squared. Squared, the whole thing's to the 3/2 power. Now I'm just going to plunk in the x and solve this problem.
Whoa, it's getting smaller as we go up.
Who knew?
200 divided by 100. We're good.
Wait, it's.
Bam.
What did you get?
For which one?
A.
9.22 times 76.
Where did it? 1,074.
7.2 times 10 to the 4th x over
I don't get the
0.02 squared plus 0.05 squared to the 3/2. Oh, wait, I need 0.02. 0.02. So 7.2 exponent 4 times 0.02 divided by parentheses 0.02 squared plus 0.05 squared in parentheses to the 1.5. Bam. I didn't get either one of your answers, did I?
No, that's what I got.
That's what you got.
Actually, 9220734.
No, it's not, because significant digits.
That's why.
5 centimeter ring. We're both wrong. It's 9 times 10 to the 6 newtons per coulomb. Plus or minus 1 whole million newtons per coulomb.
If I don't have to use sig figs in chemistry, I don't need them physics.
Recording this for later. Let me pause it.
Can you?
Yes.
Saying is how far you are from the center is the x, and this is the radius, right?
Okay. Yeah, I guess that makes sense.
So from here, the reason why this is true is this is cosine, right? Cosine would be adjacent over hypotenuse.
Yeah.
And then this piece here is how far it's the radius squared, right? Well, the radius would be Pythagoras, a squared plus x squared square root. But if I square it, it d square roots it.
Yeah.
And then I put them together as a 3/2 power.
Wait, hold on. The last part you put them together.
This is to the first power, right?
Yeah.
So I've got a square root of the same thing as I got inside the thing, right? So when you multiply, and the base is the same, you add the exponents. 1 plus 1/2
Why
is
do you
3/2.
have to multiply again? There.
Well, because I'm multiplying two fractions together, it's cosine times this. These are multiplied together. So I wrote this is my cosine right here. This expression is my cosine. This is my distance between the two.
And that's your
When I
cosine.
multiply them together, Cosine is the adjacent, which is x, over the hypotenuse, which is Pythagoras, would be that.
But doesn't it give you some of that already?
No.
Like, it gives.
It gives you x at a.
Yeah.
It doesn't give you the.
Then since you multiplied the two Pythagoras products, it becomes just squared, right?
Yeah, because it's radius squared, it becomes this squared, right? That squared.
Yeah.
And that squared is going to be,
Just x squared
Without
plus
squared,
a
right?
squared.
and then I've got something in the first power times something with square root bar on it. So again, that's 1/2 power, so I add the exponents.
I mean, why'd you do that stuff? Why don't we just simplify it down to the last little bit and then keep it that way?
That's, well, I tried to get it to here. Once I got to here, I'm just going to plunk in numbers.
But why do we even need to do the first step if we have that last step?
Because theoretically what they want you to do is be able to derive your own equation for electrical fields. They want you to at least experience the joy that is that. Because when you get to college and you have to take an E&M course, they're going to start off with something, they're going to start off with these wires and these sticks and these rest of it. And they're going to move over to Gauss at some point, okay? Just like we're doing now. There's no difference. There are times Gauss doesn't work, and we're going to explain explicitly when Gauss doesn't work. You're going to know when Gauss doesn't work. Gauss is always an approximation. It's never the right answer. Well, I shouldn't say that. If you had a perfect universe, it would be the right answer. But it to the degree that your model is perfect, your thing's perfect. Okay, and so the risk is, there's things that you just can't Gauss. They're not Gaussable. This is one of them. The ring is not Gaussable. Nothing I can do to fix it.
In that case, you just solve for x.
In this case, I do it this way, and then because their x is what they're changing around for the various questions, I just left it in terms of x.
Yeah.
And then I'm going to start plugging things in.
Is charge density half-boy for a disk?
Charge density for a disk would be half-boy, yes. Should be measured in coulombs per meter squared, right?